Welcome to the Cosmic Pie Podcast. I'm your host, Wayne Barkhouse.
And I'm Robert Moore.
This is episode number 37, season 3, Robert.
Yep.
We're counting up rapidly here.
That's it. And, considering there should be 52, and there's not going to be.
We did have them over the summer.
We did.
Which we didn't have to, but we did.
Yeah, but then we missed a few for various vacations and things like
Illness.
that. Illness, yeah.
Holidays.
Holidays.
It all adds up, doesn't it?
Hollandaise. Oh, wait.
You're thinking of the gas station?
I'm thinking of the nice buttery cream sauce.
We are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota, where winter has finally
arrived.
Finally arrived.
Yeah.
Emphasis on finally.
Finally. It's been warmer than it should be, folks.
And we did get a dusting of snow throughout the night and into the day. We were forecast initially, I think, for a lot more, several inches.
Several inches.
We're getting less than an inch by the looks of it. At least a lot of it is melting anyways. So.
Yeah, I think that was more the issue, is it was all melting at the beginning.
So not a big deal now, but the temperatures are supposed to go lower, and any additional snow will stick, and we won't get rid of that till April.
It may.
It may or may not leave.
It may or may not go away then. Yeah.
Now, as a disclaimer, Robert, you always do the duty.
Oh, okay, I do the disclaimer. Okay. The opinions expressed are those of myself and Wayne. There is no relationship between us. Our opinions and the University of North Dakota, the Department of Physics.
He's not my brother or my father or my cousin. No relationship between us.
Yeah. I mean, if you get mad at anything we say,
send him hate me. Hate mail goes that way.
No, that way too. Yeah.
Yeah. So we're on our own, right?
We're on our own. Yeah.
Now, do you realize what today is?
November 25th?
Yeah, so 1 month from now, you know what I hope to be doing?
I know what I hope to be doing.
I hope to be laying on a couch.
Yep.
At this time of the day.
Yep.
Watching Christmas Story or something.
Okay.
Sipping on a cup of hot chocolate with one of those marshmallows, floating on the top.
Yep.
And enjoying and admiring the Christmas gift that you gave me underneath my tree laying.
Oh, okay.
That's what I hope to be doing.
We'll have to see.
Only kidding. Only kidding, Robert.
I got to admit,
Only
I
kidding.
won't be anywhere in the state on the 25th.
You're leaving me, aren't you?
I'm leaving you. Yep.
You're leaving me for Christmas.
I'll be back, but...
But you did make an impact,
Oh?
This month especially.
Oh?
And that impact happened on Veterans Day, the evening of.
Oh, it did, didn't it? Yeah.
It did. And in fact, it made an impact on a lot of people around the world.
Yes, it did. A lot of people are asking questions.
Now, we didn't broadcast on the Veterans Day out of the fact, number one, respect for the veterans. Number two, it was a holiday officially, so the university was closed.
And they get a little upset with us when we're on campus without good reason.
Well, we don't know, but I just don't want to slip and fall and then say, oh, I need health insurance from the university. And they might say, why were you there on a holiday when the university was closed?
The university was closed.
So it's better maybe not to do that unless you really have to.
Right.
So, and they are gracious enough to allow us to do this.
Yes.
And we'll always remember that, of course. And we do always
So we do
remember
try to keep things on an even keel with the university.
Yeah.
Absolutely.
But the night of November 11th, we had a huge display of aurora activity.
Yeah.
Both in the south and in the north. And the north, of course, is what we observe.
Mm-hmm.
In fact, the northern lights were visible all the way down. Some people report it in Florida. I even heard reports, in southern Texas, even into Puerto Rico.
Right.
So it's one of those once in a few year events, but actually it happened back in May of 2024.
Yep.
And you want to maybe talk a little bit about the reason why the Northern Lights have been so active recently?
Sure. I looked it up because I've got a lot of my friends that live down south, if you haven't figured it out by my accent. Why are we all of a sudden seeing aurora all the time down in the south? And the answer is you're still not. We're having an unusually strong solar maximum, and the solar cycle is about 11 years. So this one is proving to be the first strong cycle we've had in quite a while. So when the solar activity ramps up, you get a lot more chances for aurora to happen, and a lot stronger aurora to happen. And the last solar maximum occurred in 2014, and I looked it up because I saw in Georgia the aurora in 2011. And it just happened because I happened to be outside for a night observation with our students at the University of West Georgia, and we happened to notice them. So the last solar maximum had this same type of thing occurring. So it's not that unusual. It's just it only happens at solar maximum or right around there. So that's what's going on.
Now, do you want to start by showing? I mean, there's been pictures all over the place,
Over
all
the
over
internet.
social media and all television.
But I was out at the Space Studies Observatory, and we were trying to image and everything. And please excuse the jittery stars in one of these. But I pulled out my phone when I started noticing them. It destroyed any chance we had at actually doing telescope observations. But I was holding my phone as steady as I could for 3-second exposures, and these are some of the images that I got. So the one on the left was directly overhead, because here in North Dakota, they were down to the southern horizon, from north all the way to the south. So the one on the left was almost directly overhead and looked like just an explosion that happened in the middle of the sky. And then as you can see on the one on the right, you can see Orion in the low part of the middle, the constellation Orion, that is. So this was due east, essentially. And I got a bunch more, but these were some of the better ones that showed that nice crimson red aurora that was going on. I mean, it was as bright as full moon out at the observatory.
Yeah, and so one of the things I noticed, because I was outside taking the photos also, is that at least on the night of November 11th, and this was a multi-day event,
Yes, because it happened the next night too.
the next night too, and there was even some aurora even the following night, but it sort of got weaker and weaker and weaker.
Right.
The first night was definitely the better night. And to get a good view of these things, get away from the city lights.
Get away from the city. Yeah.
I mean, that's like a lot of things that happen in astronomy, whether you're looking for like meteor showers and all these things. Things are improved greatly if you can get away from the light pollution.
Right.
And one of the things that I noticed right away when I was looking at the aurora on the first night on November the 11th is how red it was compared to normal. Normally, it's
Normally
not
it's
like
green
that.
and purple.
Yeah.
This was crimson.
And people
bright red.
people often wonder, why do you have these different colors? Well, excuse me, it's due to the interaction of the different types of atoms
Yep.
that's in our atmosphere.
So the green ones are primarily nitrogen and oxygen molecules. So you've got the O2 and the N2, and that's why those are common, because most of the atmosphere of Earth is nitrogen with a strong contamination of oxygen. So the green comes from that. This crimson, if I'm remembering, is high-level ionized nitrogen, oxygen.
Oxygen.
Okay. So it's higher altitude, and this is why, generally speaking, when you do see them in the south, you're seeing these red aurora, and it's because that's very high altitude. We're talking, I think about 100 kilometers, 120,
Yeah, so it's
something like that.
so you get the charged particles ultimately came from the sun,
Right.
colliding with the oxygen atoms themselves at high altitudes, and
Right.
high meaning about 150 miles above or 240 kilometers or so.
Okay, so it's even higher than I was thinking.
Yeah, and the red light that's emitted is actually at about 630 nanometers.
Oh, wow. So it's red.
It is red, yeah, for sure.
So nice. But yeah, that's the different colors mean different types of interactions with various atoms and molecules in the atmosphere, and they occur at different altitudes because as you get lower in the atmosphere and into the major atmosphere, actually it gets cooler again. And so you get a lot more of the molecular structure stuff going on, whereas at the altitude that these reds are happening, you've got it constantly being heated by particles from the sun, the solar wind slamming into it. And that's why it's called the ionosphere.
Now, can you maybe explain a little bit why is it that we see the northern lights like near the magnetic north and south pole of the Earth?
Because we've got a deflector screen. And so all these charged particles follow magnetic fields. And so they hit the Earth's magnetic field. Number one, they start making it shake. But number two, the particles follow the field lines, which trace the paths to the north and south poles, magnetic poles. And that's also why it's the aurora oval, as it's called, is drifted a little bit towards Europe, actually, is because that's where the magnetic pole is. And that's where these particles come screaming into the atmosphere.
Now, some of you are disappointed because maybe you had cloudy skies when this activity was occurring, or you just didn't really hear about it until after the event was over, or you couldn't get away from the city lights at the time. Don't worry, it's going to happen again.
It's going to happen again, yeah.
And especially now because we're basically at solar maximum. We don't really know when solar maximum occurs until after we're past the peak.
Yeah.
And the activity starts dying out. And then we can look back and say, okay, this is the month where it sort of was at its maximum in the past.
Right.
That's number one. And the other thing is it can occur for many years after solar maximum.
Right. The average period of the solar cycle is 11 years, but it can be as short as 9 or as long as 14.
Well, you already mentioned that the peak, which was in 2014 last, and you've seen the display from Georgia 2011.
2011.
That was clearly 3 years before the peak.
Yes.
So it could occur on either side of that peak year.
But it's going to be near the peak.
It's going to be near the peak. The probability of it happening is greater when you're near the peak.
Yes.
So over the next couple of years, we should expect
To
additional
see this one or
aurora.
two more times.
Yeah. So that it'll occur again. Again, you don't have to wait another 11 years or something for it to cycle through.
And I like to point out that if you go 11 years from 2014, I didn't look up when the one before that was, but it would have put it around 2000.
Right.
And to be honest, I was in the middle of New Orleans. Had I not just known about it to drive out of town, would have never seen it. And that's what's happening a lot of times is in the past, there weren't ubiquitous cameras carried around by all of us. And when you look up at the night sky at this, even if you are in a dark location, to be honest, to your eye, it just looks like clouds. It does not look all bright and everything. It just looks like clouds. So, yeah.
Okay, so the other thing is one of the major things we've been discussing in the last several months have been comets.
There have been comets.
In fact, and it's not just the one comet, the Three-Eye Atlas, the interstellar comet that everybody seems to be talking about. The other thing we talked about is additional comets, including this one. And then we talked about this in the last podcast. In fact, here is a slide from the last podcast that we did. And this is Comet 2025 K1 Atlas. Atlas is the survey that they're looking for that found it. So there's multiple comets that have been tagged with the word Atlas. So you have to look at the rest of the name of the comet to figure out which one it actually is. And this one was very interesting. It passed the closest point to the sun, which was about 33% of the distance from the Earth to the sun.
Okay.
So fairly close. So
fairly close.
the distance from the Earth to the sun, we call that 1 astronomical unit. So this comet passed within 0.33 AU of the sun. So
Okay.
it's closer than Mercury.
Right.
And one of the things that was expected, and this happened back in the early part of October, was that the comet potentially could break into multiple pieces.
Okay. Now, how did they know it might break up into multiple pieces?
Number one, it has to do with the sort of intrinsic structure of the comets themselves.
Okay.
And we've visited several comets already. In fact, we've landed a probe, the Fly mission on the comet, right, from the Rosetta spacecraft. And so we have a good idea of the tensile strength, if you like, of comets themselves. And they're not held together very strongly.
Right.
So it doesn't take a lot to break them up. And the other thing is, they produce, obviously, the coma, the head part of the comet, and then the long tail. And that's due to essentially the evaporation of volatile-type material.
Right.
So it sublimes.
So it sublimates.
Yeah, it sublimates. And that causes then, if you like, a decrease in the strength of the object in order to maintain itself by its own gravity, holding itself together.
Okay.
And it doesn't take much to get near the sun. Not only have a lot of the heating effect, so absorbs a lot of energy from the sun. You'll have a lot of outgassing that can occur.
Right.
The material itself can be full of pockets, and we know that, in crevices and cracks. We've seen that on, like I said, the Rosetta mission, the comet, the 67P comet that it landed on. Saw evidence of that. So we know it's like, it reminds me of, like the movie, what was the movie that you could see, was it 2000 and, do you remember the one of 2010, was it?
I don't
Where
know.
the everything was breaking up. There was a major earthquake on the Earth and stuff, and I think it was 2010. And they showed LA, it was all breaking up, and people had to jump on jets to get out of there in a big hurry.
Yeah, no, I don't remember.
You remember
at
that
all.
movie? I think that's the name of it. Anyways, I can look it up later. But it's like that kind of thing. Like, it's just like the worst case scenario of the apocalypse you can think of, where you have major earthquakes, buildings falling down all beside you, cracks in the ground, everything is falling in, all that kind of
Okay.
stuff. Except that's the surface of the comet
Right.
when it's in this sort of situation. And so because of the gravitational tidal effects and so on from the sun, combined with the stuff that we talked about already, the comets in general can be torn apart. And we've seen that multiple times. It's nothing new, right? So when this comet passed by the sun, when we were in our last podcast, was a week before November the 11th, the comet then displayed an image that it was a single piece. It had survived the close approach to the sun itself.
Right.
But since November the 11th, this is another November 11th, just coincidentally, observations made of the comet through telescopes indicated that there were actually 3 pieces
Right.
of the comet.
And this kind of makes sense. When it is close in, it's moving really fast. Conservation of momentum keeps all the pieces moving in the same direction at roughly the same speed. But as it moves away, they start experiencing different levels of gravity and start moving apart a little bit.
I mean, that's the classic example of an object that blows up in explosion. It doesn't move violently away from you.
Right.
You're all traveling along in the same trajectory. Just the pieces have the little bit additional sort of velocity, right, associated with them and going in slightly different directions, and it can spread apart gradually like that.
Right.
But essentially, the momentum of the system stays the same, in the same location. It's just the extent of the object
It's
spreads
the
out.
extent it
Yeah.
spreads out.
So this was the image that you see here was observed then by a 1.82 meter telescope, the Copernicus telescope in Italy. And you can clearly see there's several distinct features at the head part of the comet itself. So that would be on the left side. Now, an image that was taken just 2 days later, this is a 60-second exposure on November 13th, shows the individual pieces quite well. And right now, the comet, this particular comet, is not too far away from the North Star.
Yep.
So this is a comet where finally we're the ones that get to see it in the northern hemisphere. And if you live in the south, well, I'm sorry, you've seen enough comets in the past 20 years. You got your full share. It's our turn.
Yeah.
Not
Not that this one's going to be really bright, folks.
It's not going to be really bright, but if you have a telescope, you'll be able to look at it and see the individual pieces depending on how well your telescope is and what is the seeing conditions you're looking at and that kind of stuff, right? So, so it'd be interesting to see. This comet is definitely disintegrating
Absolutely. Yeah.
and breaking up into multiple pieces.
I'll be interested to see if it breaks up even further.
Yeah, and I think it seems to be that's what's happening, but stay tuned for that one.
Yep.
But speaking about comets,
Our good old friend.
a good old friend, Comet 3I Atlas, the third interstellar object ever discovered.
Yes.
This one being a comet. The first one, Oumuamua, was an asteroid-like object. The second, Borisov, was definitely a comet with the standard coma and tail of a comet. And same with this one, the 3I Atlas is definitely a comet with the head and the tail and so on. And since our last podcast,
Oh, Lord.
NASA, with the government now reopened in the United States, NASA was able to release all of the information that they had taken by various space probes of the comet itself. And sort of a personal opinion here, those were really disappointing, those images.
They were. I mean, they were nothing like this.
Yeah, this is a ground-based image taken by an amateur astronomer. And this is taken in the early morning, of course, when it's still dark before the sun comes up. And this is way better than anything that NASA released.
Right.
Which is not surprising because NASA's photos were taken by spacecraft that were not designed to take cometary images. They were designed to do other things, even including the rover on Mars, right? It's designed to look out into space or looking on the ground. It wasn't designed to look out in space, right?
Right.
So it wants to take pictures of landscapes, things that are a lot closer than looking at a distant comet. So it wasn't able to control the exposure time long enough to get a decent image that I noticed, and it can't track the comet, so it makes it blurred.
Reasonably well lit and all this, so short exposure times, and
not good.
Yeah,
not good at all.
But I mean, I love this picture because it shows all that nice bluish green of the cyano ions,
Bacteria.
So the carbon molecules and everything. Classic.
I was waiting for you to say cyanobacteria.
No, not cyanobacteria.
Damn. We could go down the alien
the
rabbit hole again.
Yeah, the reason cyanobacteria is blue-green, though, has to deal with the fact that the chlorophyll has cyanogen compounds in it. So, that carbon-nitrogen bond glows green.
It was interesting to note when NASA did release the images and had a press conference about it, they made sure that they made the statement that all indications are this object is a comet.
Yeah. It's crazy that they have to do that and that we have to keep revisiting it.
Looks like a comet, smells like a comet, walks like a comet, quacks like a comet.
Probably is.
It probably is a comet.
And we still got that one guy that's, no, it's changing course unlike, outgassing.
You mean the fraudster?
Yeah. And it's like, he's selling books, folks.
Yeah.
Okay, he's getting advertising out of this. Of course he's going to step up and say, hey, this is what it really is.
Yeah, I mean, there's one thing to say that, you can't not rule out all possibilities of different things, and you should have an open mind in science. But how does the saying go? You don't want to have too open a mind that your brain falls out.
Falls out, right.
I mean, come on. I mean, a lot of stuff, and I don't want to going off about this person again, but when you make statements like it's a 30 to 40% chance as an alien spacecraft, it's
you better have some evidence to back that up.
I mean, if he was at our institution, I'd want evidence for that. That's just fraudulent statements.
That's fraud.
Right?
Yeah.
And that's given science a real bad name, unfortunately. It's bad enough you got to worry about science when it comes to public opinion from people who don't know anything about the science that they're talking about,
right.
Whether it's politician or the average person in the street, right? I mean, why do we have experts in anything?
All right.
Right?
Bingo. I mean, you don't go to the plumber to fix your car.
Yeah.
So sorry, you don't, anyway.
Same thing. You don't go to your landscaper to get a heart
transplant.
Heart surgery done or something, right? I mean,
now,
that's what the experts are for.
If my tree is diseased or got some kind of infestation, I'm calling my landscaper,
If your tree rises in the middle of the night and looks like a disc-shaped object, then you go the other way.
Yeah.
And you got an implant in the back of your head, well, then maybe there's something, But yeah, it's foolish, and I wish that would go away, but that's been here forever.
It is. I mean, people say ordinary comets from inside the solar system are actually alien spacecraft, so it's not terribly surprising that you got a few that are trying to say that.
But
this interstellar one.
I like what Carl Sagan used to say, back probably in the 80s, I guess it would be, or even in the 70s. He would say, and back then, of course, we didn't have the internet and all the social media stuff. So he would talk about astrology.
Okay.
The fact that somehow the placement of where the planets are in space relative to stars has something to do with what's going to happen to you in your life.
Right.
He said, do you realize that every major newspaper in the country, and that is the United States, publishes a column on horoscopes, a daily column?
Yeah.
And hardly any of them publish a column on astronomy.
Right.
So what kind of society are we living in?
Yeah. That's a good point. Yeah. I used to point out to my intro astronomy students, go stand 20 feet away from one of those big Ford Explorer SUVs. That Explorer has more of a gravitational influence on you than Jupiter does. It's like, come on, folks.
Well, besides a Ford Explorer, what you really want to do is use the Escape.
Yeah.
Escapade, in other words.
Escape.
Escapade. That was launched finally. This happened too since our last podcast. We talked about this coming up. So this was the launch of the New Glenn rocket back on November the 13th that launched Escapade to Mars. Well, not directly.
Well,
It's in a holding pattern right now.
Okay.
It's kind of proving out something, a new idea, a novel idea. And the novel idea is if you want to send a spacecraft to Mars, you have to wait for the planetary alignment to be just so.
Yep.
And that way you can minimize your fuel consumption. Therefore, you can go on maybe a smaller rocket that costs less. You know, all these factors. It's all money. Everything is money. Money, 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 money.
Yeah.
Okay. Now, at the time when the Mars alignment is correct, because of the increased activity of us wanting to explore that planet, at any given sort of several month window, there's going to be a lot of rockets needing to be launched to send their payload on to Mars. And maybe this will become even more so in the future when
Right.
humans decided to eventually get to Mars and do some exploration. There could be transfers happening all the time with equipment, and there'll be multiple launches. Well, you know, of course, if you have bad weather, that'll delay things, and the schedule gets pushed back, and people are waiting to go up for their turn. Maybe it's like waiting on the runway in a rainstorm for your plane to get the clearance to take off, and there's 10 other aircraft in front of you, right?
Right.
What do? You sit back and, oh no, here we go, right? We're number 7 on the runway. We're number 4 on the run. You know, it's that kind of thing. You're waiting and waiting. Well, if the window closes before you get up, you're done. You have to wait another roughly 2 years for the alignment to be correct again, right?
Right.
So the idea that people have had is that instead of waiting for the alignment, let's launch our rockets, our spacecraft, early. That is, before the alignment occurs. So there's less demand. No one wants to launch to Mars then.
Right.
So you got the whole thing to yourself, in some sense, for Mars launches. Let's launch our payload, but let's put it in a parking type orbit
Okay.
near the Earth, and we'll just sit on it and wait. And then when the alignment opens up again, then we'll send that spacecraft onto Mars. Number one, you did the worst thing, the hardest thing, and that's get it into space to begin with.
Right.
So it safely makes it into space. And the next thing, once you have a payload in space, there's really not a huge amount of force that you need energy-wise to get that payload onto a Mars crossing or interception orbit.
Okay.
It's a lot easier.
Yeah.
And that was the ideal here. So they launched the Escapade, which is a twin spacecraft to study the magnetic field around Mars.
Okay.
And it was a test of the New Glenn rocket. So it was one of these heavy lift rockets.
Okay.
So the chance of something going wrong is not small, but
Yep.
they're willing to take the chance. The people who build the payload said, we'll take a chance, we'll ride on the rocket. And everything worked.
Nice.
And that's really good to see because that really puts them, that is Blue Origin, in competition directly with SpaceX now.
Which is the best thing to have. Now, I do have to ask something, and maybe you don't know the answer. I'm looking at the exhaust coming out of the back end of that rocket. That's a methane-fueled rocket, isn't it?
If it turns green when you first ignite it, that's methane. That's
Okay.
the telltale signature.
I'm just looking at the almost translucent blue,
Right.
and that's an indicator often. Think about Bunsen burners or the gas on your stove. You know, they burn that nice translucent blue. So I'm wondering if it's a methane rocket.
So the
Liquid oxygen methane.
yeah, so it works on liquid oxygen and liquefied natural gas.
Okay, there we go.
That's what it runs off at. That's for the first stage. The second stage, it runs off liquid oxygen and liquid hydrogen
Okay,
for its
so
upper stage.
It's LOX.
Yeah. So
Okay.
LNG is the source of fuel for the first stage.
Nice.
Yeah, pretty cool. And that's why it looks like your Bunsen burner. So it fits right in with that.
Cool.
Yeah, so,
So they apparently did something else though with the Glenn rocket.
yeah. So the other important thing that happened with the rocket is that they landed the first stage. Now, the first stage is 7 engines. You don't want to dump that in the ocean every time,
Right.
especially if you can recover it and then refurbish those engines, because those are really expensive, obviously. And so that will cut down the cost of launching for everybody who's interested in using the service. So they stuck the landing on the barge, and it's very similar to what you see with the SpaceX. Now, it was interesting. I was watching this live at the time when it occurred.
Okay, cool.
And one of the things that I noticed, and I was there with another person, we were both watching this, was that you could see the barge. So there was a camera on board that was filming everything. And then all of a sudden you saw the water being disturbed near the barge, which was a clear indication that the rocket was above the water. And it was like, oh no, it just missed the barge. That's the idea, right?
Okay.
But what I discovered later on by listening to Blue Origin talk about the launch was that they purposely had the first stage come down and hover over the water in case of a problem. So it would crash in the ocean and not destroy their barge, which would cost money to fix.
To fix then.
Once they got the rocket hovering and stabilized, they moved it sideways until it was over the barge, and then down it came on the landing gear that you see there.
Nice. Okay.
So it was all done on
That makes
purpose.
sense. That makes
But it's
sense.
pretty cool that you can do that. And if you watch the landings of the rocket when they sent up the suborbital flights, right, they have a very good landing system, right?
Right.
They stick that landing every time, right? They're so good at it now. So they got lots of experience doing this kind of stuff. And what they said was once they're 100% sure, well, you're never 100% sure, but once you have good reliability indicators of the first stage landing on the barge, then they'll skip that step. They'll just come directly down on the barge.
Okay.
Okay, so
can
that just
buy that
tell
for
you
$1.
how cautious they were of this launch,
Yeah.
which means you took a high risk putting your payload on board this rocket. You see,
Yeah.
as a customer,
At the same time, they probably got a cost break. because
I'm
of
sure they did. In fact, the trajectory that we alluded to already about where does the Escapade spacecraft go, you can see that on the right-hand side if you can make out that plot. And so one of the things it does, it orbits around what we call the Lagrangian 2 position.
it. Okay.
So this is the position away from the Earth, away from the sun in the opposite direction.
Okay.
And it's the spot which has a roughly stable, gravitational-wise, a stable position.
Right.
And it takes less fuel to maintain that position. In fact, that's where we find the James Webb Space Telescope and a host of other spacecraft are in that area. And so these Escapade spacecraft are going to sort of orbit around the L2 position for about 11 months or so in total. And then they'll make their way using the gravitational slingshot of the Earth, they'll make their way onto Mars.
Nice.
And so they'll be there, for an orbit around Mars itself, hopefully making
That's-
measurements of its magnetic field.
That cruise to Mars is a great indicator, a great picture of a transfer orbit.
And that's the blue curve that you see there.
Yeah. Because most people don't realize it is actually an orbit around the sun.
Yep.
And it's an intersecting orbit from where you are to where you want to be.
Yeah. I don't like to use this analogy, but I will.
No?
Great statement, right?
Yeah.
It's like shooting ducks. You want to shoot in front of the duck, not at the duck.
Right.
Because you want to time it out so by the time the shot gets to the position of the location of the duck is there at that spot also.
Right.
If you aim at the duck is not there anymore by the time the shot gets there.
Yes. Yes. You are correct. Having done duck hunting.
Yeah, so you got to, lead the shot, if you like, right, in front
Yep.
of the duck. Same here. You have to time it out so that essentially the spacecraft will arrive at Mars's orbit at the same time Mars is there at that location.
Because otherwise you got to slow down or speed up.
Yeah, and it costs more money because you need rockets to do that and then all that effort. And so we know where the planets are very, very accurately. We know the trajectory that our rockets will take very, very accurately. So it's very easy to actually figure out what is the type of orbital path that they should take to intercept planets like Mars and so on.
And again, that path is an orbit itself.
Yeah, definitely. If Mars wasn't there, if you just randomly sent it off,
It would just circle.
it would
back
just
around.
it would just continue to orbit the sun,
Yep.
going out as far as Mars's orbit and then back in towards
And
Earth's
depending
orbit.
on the inclination, eventually Mars would be there
Yeah.
sooner or later.
Yeah. So it's pretty cool when you think about it. So we have another, if you like, option
Yes.
to putting
and I like that.
payload in space,
Options are good.
both for customers and for the government and everybody else would be happy, right? Private people. Okay. Now the next thing is, what are they going to do in terms of manned flight? So we
thought
should
you
have a statement about that first. And what I'm thinking is both Blue Origin and SpaceX have been given contracts to develop a lunar lander for the Artemis mission.
Right.
Now, a lot of people are, if you like, worried that SpaceX is not going to have Starship developed to the point where they can actually carry humans from lunar orbit down to the surface and back again.
Right.
that's going to be pushed off to a lot more years into the future than what we had hoped. And then we'll see what happens. We don't know. But the Blue Origin itself, with this landing type of technology that they have, they're in the game as well. And they're looking at developing basically a super duper lunar module type of vehicle.
Okay.
That could easily go from lunar orbit down to the surface and back again. So we'll see how all this plays out.
Right.
Right now, the latest I heard was it won't be till at least 2028 that people can go back to the moon because of the lunar landing development schedule being so far behind.
Yeah.
There was a lot of emphasis put on the rocket itself, the SLS system.
Right.
I don't think they put enough on the lunar lander.
And that's always the case.
But even in the
focus
Apollo,
on one thing and the other things go behind.
well, even in the
shed.
Apollo project, it was the same thing that happened. You think that we would learn. The lunar module was delayed in its production to the point when Apollo 8 went up, there was no lunar module to play with in Earth orbit to check it out. So that's when NASA decided, and plus word was coming down the pipeline, I guess, at the time, that the Soviet Union was ready to launch a very large rocket. So they thought, the United States thought they were going to get beat to the moon by the Soviet Union. That's when the United States decided to launch Apollo 8 to go around the moon, to go in orbit around the moon. Because they didn't have a lunar module, none was ready to go, you see?
Right.
And they wanted to put a stamp, say we were to the moon first, at least in orbit around the moon. In fact, the Soviet Union, as the story was told later, when stuff became declassified, was they had a lot of problems with their heavy rocket.
Right.
And at one point, there was a major explosion on the launch pad, and a lot of people got killed. And that set back their project dramatically.
Well, the SpaceX is showing it's a big thing to launch a
It
big
is.
rocket.
And the Soviet Union go with, instead of having several large rocket engines, they go with a bunch of small ones, but have lots of them, 20, 30, 40 of them type of thing. Almost like SpaceX does the same kind of thing with the Starship, if you see it. And the same kind of thing the Soviet Union was doing. And they all got to be timed right. They all got to be light off, at the right time so they don't destroy. You can't light them off at once because I think the whole thing would be too much of a vibration for it. So they're sequenced to light off at different times and so on.
But it's like tightening your lug nuts. You've got to do it in the right sequence, the right order, and the right position.
Yeah. And so there are a lot of stuff. Plus, the technology wasn't as proven back in the 60s as it is today. The rocket technology was still a new thing back then, where the United States went for the much simpler of having 5 F1 engines in the first stage of the Saturn V. That was easier to control in that sense. And the other thing is redundancy. If one of the engine fails, you just keep the existing fuel and oxygen source pumping through the remaining 4 and run them longer. To try to compensate for the loss that you're experiencing.
Loss of thrust.
Yeah. And that was important, right? Because I think it was, which mission was it? Was it Apollo 13, right? When they shut down, the center engine shut down, and they had to burn the remaining 4 for a little bit longer because of that. And so that's where it came into handy, right?
And then they had the
Then they had the real problem, right?
Then they had the real problem.
So
and in fact, it's on radio that they even said, well, we're the number 13. There's our unlucky glitch.
Yeah.
Yeah, about that.
Yeah, exactly. Okay, so it's very interesting seeing all this development in rocket technology. You never know where things are going to go in the next 5 to 10 years. So it's definitely worth paying attention to. The other thing, speaking about paying attention to things, this is an update on a story that we talked about several months ago. Right now, the United States, as well as other countries involved, are planning these very large telescopes, right? Extremely large telescopes. There is an equivalent, roughly a 30-meter class telescope that we want to put in the south, in Chile. So this is the Giant Magellan Telescope. It's nearly equivalent to a 30-meter diameter mirror, almost. And the second extremely large telescope that the United States wants, as well as other countries I mentioned, wants to put up is this one here, the 30-meter telescope. This was destined to be put on top of Mauna Kea in Hawaii.
Right.
And the idea is the 30-meter telescope, the TMT as they call it, will be able to observe everything in the northern hemisphere. And then the Giant Magellan Telescope would be able to observe everything in the southern hemisphere.
Okay.
So you got the whole sky.
With some overlap.
With some overlap, but you have the whole sky covered.
Right.
Now, on top of that, we have the Europeans. So the European Southern Observatory, they're constructing right now a 39-meter telescope, but it's in the south. Now, there's reason why you want to be in the south. Number one, the center of the Milky Way is directly overhead at times. And so you have a fantastic view of what goes on in the center of our own Milky Way galaxy to study it to death, right?
Okay, that works
If you're
for
in the
me.
northern hemisphere, it's very low to the horizon. In fact, in Grand Forks, if you wanted to observe towards the center of our galaxy, you have to observe in the summertime, and you have to observe really close to the southern horizon.
It's low.
And the constellation Sagittarius.
Yeah, that was one of the disappointing things when I moved up here, when I realized how low Sagittarius is in the summer sky.
So that's not great. Because you're looking through a lot more of the atmosphere,
Yeah.
and it makes things look blurrier and dimmer, and so you don't get a good view at all. So yeah, you want to be down south to see the center of our galaxy. But unfortunately, the TMT is having a lot of political trouble. And it started from the fact that a group of individuals decided that you have enough, you astronomers, in other words, you have enough telescopes on top of Mauna Kea.
Right.
And according to our culture, the top of Mauna Kea is something that's very important to us. It's sacred.
It's sacred.
And if you want to put number one, we'd like to have all the telescopes removed and put Mauna Kea back to its natural state, i.e. no telescopes at all, zero. And we don't want you to put another telescope up there. In fact, we want you to remove maybe a telescope for every new one you put up.
Okay.
Maybe that. It depends who you talk to, right? There's a
Yeah.
range of opinions on all of this. And you might wonder, well, why even go through that hassle in some sense of trying to convince groups of people to allow you to do this? Why not just go somewhere else? Now, the reason why you don't like to do that is Mauna Kea turns out to be a really great site for ground-based observations of the sky. Astronomers don't place their telescopes in random locations,
Right.
right? If you have hundreds of millions of dollars and you're wanting to build a telescope, what you do is go to the various places where you think you're going to have, number one, the sky is going to be clear often. Why would you put it somewhere if it's cloudy statistically from climate data 300 nights of the year? You're not going to put your
I
telescope there.
wouldn't want it there. Yeah.
Number two, you also want to put it in a place where the atmosphere is less turbulent. So the seeing, as we call it, is better. And that means whatever images you take of the night sky on a clear night, the seeing is nice and the images are nice and sharp, high resolution, at least as best as you can get.
Right.
And a good indication of that for those who just look at the sky occasionally is the twinkling effect. When you look at stars twinkling, that's due to the atmosphere. If you were in space, stars don't twinkle.
Right.
Okay? And more they twinkle, and some nights you'll notice, for example, stars twinkling more than others, or even better, you can look at above your head at the zenith position. Look at how the stars are twinkling directly above you. Now look at stars near the horizon. You'll see they're twinkling a lot more because that starlight has to pass through a longer path length, as we say, through the
Lot more
atmosphere.
atmosphere.
So more of a blurring, a turbulent effect occurs to that light. So you want to put your telescope in places where that effect is minimal.
Right.
Okay, so you want to put it in places, as we say, of good seeing. Mauna Kea is one of the best places in the world to put a telescope because of those combination of being
Yep.
clear often and great seeing. And so that's prime real estate for an astronomer.
Some of that great seeing comes about because it's what, 18,000 feet high?
Yes, and you get a nice laminar flow of air from
Right.
the ocean over the top of the extinct, hopefully, volcano. See?
Yep.
And it makes the air above the telescope then less turbulent than some random location like outside the Grand Forks here in North Dakota.
Right.
We don't have that advantage of that laminar flow. And so you get a lot more turbulence. And so the seeing is worse on average here. So you don't want to put $100 million or more, or $1 billion in this case, telescope in North Dakota. Unfortunately, we can put the control center there,
Right.
and I'm all for that.
Yeah.
To hire people and employ people to work at the control center, but the actual telescope itself is on top of Mauna Kea. We could do that. We have telescopes in space. We don't have to be looking through the eyepiece of a telescope to use it.
Right.
Right? We can do all that remotely. Now, what's going on with the 30-meter telescope, just sort of an update, is that it's basically bogged down in legal arguments. The state of Hawaii everything is basically shut down. There's nothing being done. And it has nothing been done for years now.
Right.
Astronomers are very patient, and they know this is such a great site, you don't want to make people mad any more than what they are. So they're willing to take the time, number one, to explain the benefit of the telescope. It's one of those things that's designed to look at the sky. It's not an oil refinery. It's not a nuclear power plant. It's not a coal plant where ultimately, even though you have good intentions of making electricity cheap for people, you pollute the environment. I'm sorry, it does happen. The telescope doesn't do that, right? It's really minimum sort of impact on the world. In fact, you're advancing our technology, you're promoting science and education to our young generation, and hopefully motivating them that they want to learn and they want to go to places like University of North Dakota and get higher education. So it's a good thing overall. Okay, there is a bit of pollution, right? I mean, people have to go to the telescope occasionally and do things, and you have to fly on an airplane. Yes, and that causes pollution. But it's minimal compared to other things that we do.
Right.
So from that point of view, we have no negative impact to the environment. Now, of course, there is this other aspect where this is part of sort of a religious type of culture, if you want to use those words. And so that disturbs people. And we recognize that. Okay, we understand that. Is there any way that we can live together? I mean, it's not unlike a situation where hundreds of years ago in the past, some group of individuals militarily took over your land.
Yeah.
And now every generation is forever mad because of these group of people that took over your land. But are you going to change it? Are you going to say, okay, everybody please leave this individual country because really it's not your country. If you go back 10,000 years ago, it was run by us, not you. You invade it in some sense. So please move back to wherever you're.
Right.
That's never going to happen. You know that. So we need to get along for the benefit of everybody. So we can get along here, one would think. But that's not really what has happened up to this point. So everything is basically on hold. But time is running out. You can't wait forever on these things.
Right.
As I mentioned, the Europeans are soon going to have their telescope operating in the south. And so anything that they can see with the telescope that you need that large aperture to see, the low-hanging fruit, they're going to get all of that.
Yep.
They're going to do those observations. They're going to publish those papers, you see?
And therefore render it kind of obsolete.
So the United States right now cannot afford two large telescopes because ultimately, even though there's a lot of private money that go into these telescopes, these telescopes are on the order of $1 billion.
Right.
That's with a B, not an M. $1 billion. And so they need some government backing, which ultimately relies here in the United States and our funding agencies, the way they're set up. The National Science Foundation and the NSF has said, due to their budgetary restraints, right, the restrictions that they have, they can't afford both of these telescopes. So decide which one you want. Well, it's an easy decision if it was me. The easy decision is, down in Chile, where I'm building the Giant Magellan Telescope, the land has been cleared. They're still, they're almost finished, I think, making the mirrors, if not done already for it. There's no political sort of argument. It's not tied up in the court of law anywhere in Chile.
Right.
So go there. It's less of a hassle. And do not put it on Mauna Kea, where you may or may not legally be able to do it. But of course, you're going to cry as an astronomer, even if you managed to raise the capital through private funding, because Mauna Kea is one of the best sites in the world, or the best site in the world, especially in the Northern Hemisphere.
Right.
So what are you going to do? Well, what happened not too long ago is that Spain, recognizing what's going on here, they offered the TMT Corporation that will give you money and also allow you to build your telescope on our property being the Canary Islands, La Palma.
And
And
which is a good place.
And at La Palma, that is also a good spot. It's not as good as top of Mauna Kea, just to put them in perspective here. But there's also the largest optical telescope, the Gran Telescopico, the 10.2 meter diameter telescope that's situated there already, which is mainly owned by Spain and minority share by Mexico. So they have essentially the largest optical telescope in the world now that's already there functioning. And it's a good spot to put the TMT. They they'll do the infrastructure and all that kind of stuff, and you don't get the political wrangling like you have now on top of Mauna Kea.
Right.
Now there are people that will protest everything, you know that, right?
Absolutely.
You know, if I dig a garden in the corner of my property, the right people, if I told them, they would complain about that for some reason, right?
Right.
So you're always going to have some people, but it's not wrapped up into this culture thing. That's what I don't like, right?
Right.
The fact that we're encroaching on people's sacred land, that to them is extremely important. I mean, it would almost, I'm not saying it's the same equivalent, but it would be like if I came along and I wasn't a Christian and I'm saying, your church is built on a piece of land that ultimately I would like to have. Therefore, could you please move it? I'm going to put something there.
Right.
And you're like, no, this is extremely important to my religion. I'm not moving it. It's kind of like that in a way. So we have to be very sensitive to different cultures, right?
Right.
You can't just plow them over just
like
because
you
they
said,
don't
we
think
gotta
like
get
you.
along,
We have to get along. So this is an out for the TMT. This is a way of having the TMT. Have your cake and eat it too. The TMT can then be moved to La Palma, be built there, and also have not quite as good as Mauna Kea, but good enough that they
Right.
can definitely use the telescope and get all the rewards for it. So hopefully this will occur. Having Spain financially contribute to the project might be enough that maybe the government, the U.S. government, can pony up the rest of the money for our share, whether
Yes.
it's not as big as a commitment from the National Science Foundation that otherwise it would be if Spain did not give any money as they, for the project. We'll see how it all works out. So hopefully this is a way of going through. And what this announcement is again, November the 11th, numerology here, Robert. Everything is November 11th. What happened on November 11th is that we had official statement from the TMT that they are looking officially at the proposal from Spain to build the telescope in La Palma on the Canary Islands.
Nice. I like it.
So it wasn't rejected anyways, which is a good thing. And
Yeah.
why would you? Because you're cutting off your...
Your nose spites your face.
Exactly. And we
Absolutely.
don't want to go down that route, right?
Right. So, yeah. Good deal.
We'll see what happens. Now, I don't know if you caught this interesting story. And actually, the story itself continued last night.
Okay.
And this was the Chinese space station. What happened was a crew was launched to the Chinese space station, just like when we go to the International Space Station, which in some sense is not so international when you think about it.
Right. Not anymore.
It's like the World Series, and it was
Yeah.
usually just the United States, and now, of course, we had teams in Canada since early on,
Yeah.
in Montreal and Toronto initially. Is that it really wasn't the World Series because it was only the one country, right? So it's this
Right.
kind of a thing. China sent up their astronauts, Tigonauts as they call them, to the space station, and then the vehicle that you go up with, that's your lifeboat, right? So if you're on the space station and something happens, a fire breaks out, which is a real big sort of possibility, you have to be on the alert, on your tippy toes, with this happening
Because
all the
you're in
time.
pressurized oxygen atmosphere.
Right, and you got to get out immediately, and you got to breathe that air. It's very difficult, right?
Right.
You can't like just open up a window, jump out, and run away from the house that's on fire, right?
Right.
So you got to have a lifeboat, and it makes sense. You're going to have your vehicle that you came up to the space station with as a lifeboat itself. But what happened was, and we actually had alluded to this, believe it or not, the last podcast that we did, and if you've never heard that, please, I encourage you to go back and listen to it. But we talked about all of the orbital debris,
Yes.
and that played a major factor here. What happened was the return vehicle for this particular crew, the vehicle was struck by orbital debris. And as far as they can tell, at least the information that was released, the port window that's on the spacecraft that allows the astronauts to look out was fractured, was cracked, to the point that after when they investigated, China decided it was not safe to be used to return a crew back to Earth. So they were stuck. No
Yep.
lifeboat. So what happens is a new crew came up, and it was scheduled. And the new crew that came up, they then, the old crew that was on the space station, they went back in their vehicle because they couldn't use their
Now
own
the
vehicle.
new crew doesn't have a escape boat.
So this new crew was up there now without a lifeboat. So last evening, they launched an unmanned vehicle to dock with the space station to serve as the lifeboat and the return vehicle of the crew that's currently on board the space station.
Wow. Well, this is one time where I'll say I wish I could say, I felt bad. But considering the amount that China has contributed to the debris floating around in a low orbit, I'm saying, we're due too. But, come on. You can't keep blowing up other people, even your own satellites and things like that, scattering that debris throughout the orbital paths.
Oh, but Robert, if it gives you a military advantage, those are just some of the things you have to deal with, Robert.
Yeah. Okay.
When World War III breaks out, if it ever does, and heavens forbid it never does.
Hopefully it never will.
One of the things that's going to happen is we're going to take out every satellite that's in orbit that's not part of our country, right? That could be used for military from other countries.
Pretty much keep us earthbound, because with all those satellites exploding.
Maybe that's how you know if we were able to detect civilizations on other planets, how you know that they went through a catastrophic war, is you have all this debris in orbit.
There. Yeah.
And somehow you'd be able to detect that without actually going there,
and
right?
Low planetary orbit.
Like our telescopes can detect that orbital debris or something, right? And you know that's not a place you want to visit. And there's probably nobody left anyways. All the life forms have killed themselves. Annihilation. Who knows?
It's a thing.
Yeah, so it's one of the things you got to worry about. So it's interesting. This crew was up there for several days without a lifeboat. If anything major would have happened, they were done.
They were done.
So that's the risk. You don't want to take that risk. Every time we go up to the International Space Station or anywhere else, we always try to have a redundancy, the backup plans to get back.
Right.
And it's extremely important for us. So anyways, it happens.
Okay.
Now, the other thing I wanted to mention was this. And this other thing, there was an observation done of an M-class star at a distance of about 40 light years from here, where they detected, these are radio observations, they detected a coronal mass ejection. Okay, no big deal. We get coronal mass ejections from our sun all the time. That's part of this interaction we talked about, where you have energetic particles that stream off from our sun, crash into the Earth's magnetic sphere, magnetosphere, and spiral along the magnetic field lines, and ultimately crash into the poles, crash into the upper atmosphere, generating the northern and southern lights. Right? We talked about that at the beginning today. But in this case, this coronal mass ejection that was observed was so strong that it could literally strip away the Earth's atmosphere if our sun burped out of one of these coronal mass ejections.
In other words, it would push the magnetic field so far that it'd be down inside the Earth and offer no protection.
The atmospheric particles would gain so much kinetic energy that they would essentially reach escape velocity from the Earth.
Yeah, I'm glad
so how long can you,
an M-dwarf.
Robert, how long can you actually hold your breath?
I can hold it for probably about a minute and a half.
Well, that's all you'd have left, of course, if that ever happened.
Assuming that I had warning enough to...
It's not great. In fact, it kind of, in some ways, decreases the chance of life existing on other planets. You cannot have life, at least as we know it. You can't have life living on a planet that's orbiting a star that undergoes one of these very strong energetic sort of outflows, these coronal mass ejections, and wiping out or stripping off your atmosphere every so often.
Right.
It's not going to work.
I mean, I knew that M-dwarfs were unlikely to host life simply because of the flares. And I thought we detected a CME from one of these stars before now, because flares and CMEs kind of go hand in hand. And so I knew flares, these stars burped out strong flares. That's a lot of radiation hitting the planet.
It is.
So while I think the heating, because you're tidally locked, is not a factor in determining if the planets could support life, because atmospheres are pretty good at redistributing heat. Okay? But yeah, if they're taking an impact, CME impact like this, even on the scale of a few million years, that atmosphere went away. All life on that planet just went.
And you could make the argument, oh, aren't we so lucky that we live here on Earth and Earth's sun doesn't undergo one of these extreme energetic events?
It used to.
Well, here's the thing to think about it, though. It's the reason why we're here that we know it didn't.
Right.
It's the anthropic principle. If we lived on a planet in which our host star underwent one of these events even every 100 million years, it would wipe out life on the planet Earth, and it would have to start all over again.
And aren't there G-type stars that they found that have flares on this level?
Yes, and those G-type stars are the same type of stars like our sun. So you can never rule out.
Yeah.
Can never. I'm thinking like this other guy now, right? Like you can never rule out the chance that sometime that we'd have a large solar flare or coronal mass ejection that would heat up our atmosphere to the point where it would evaporate away from the Earth.
Yeah.
And strip it. And we're done for.
We're done.
We're done at that point.
We've got a few days.
So we haven't observed any of that in recorded history.
Yeah.
But who knows going forward? You just never know.
You never know.
Now, with that bright way of ending the podcast, if you'd like to learn more about the STEM field or any education and higher learning in general, come to the University of North Dakota. We are a very friendly institution here in a great North Dakota, especially in the summertime. People are like, "Oh, I'm never going there. You guys like live in igloos." No, we don't. Even in the winter, right? It's really not that bad. You get used to it quite rapidly.
You get used to it quicker than you think.
And there's a lot of stuff to do. All of those things you want to do, like clean your house, don't do it in the summer. Do it in the winter, because that's an in-house activity you can do on those cold, winter nights or whatever, right? And then in the summertime, join the outdoors.
Right.
Just plan things a little bit more. That's all.
That's it.
And of course, we know the weather seems to be getting warmer with time. I don't know if that's a long-term type of thing or short-term, but it seems like the winters are better than what they were around here. So maybe things will improve going forward in the future. Who knows? But we have lots of very interesting programs you can take here at the University of North Dakota. What are some of those programs, Robert?
Physics and astrophysics, and there's chemistry and biology and English and history and sociology
and we miss a lot more.
We have foreign languages.
And we have lots of sports. If you're interested in hockey, of course, that's a major one. If you're into basketball and football, and by the way, our football team made it to the playoffs.
Nice. Okay.
So I think there are big games on Saturday. So things are looking up all around, you see?
Absolutely.
And when we talk about astronomy, that's important. No pun intended, or maybe it was.
Yeah.
Anyways, our next podcast will be a week from today, so that's on December the 2nd. And as it stands right now, we have a
guest. Well, he hasn't confirmed with me, but
hopefully
he will.
work out. So we'll see how that goes.
Yeah.
We always leave you with a quote at the end of our podcast. So today's quote is by someone you might have heard before, his name, Arthur C. Clarke.
Ah, good old Arthur Clarke.
And the quote is this: 2 possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying.
Clarke was a smart man.
You got it. If you like this podcast, please give us one of those. Thumbs up. Subscribe if you haven't subscribed, and we'll see you next time. Thank you for watching.
Bye, folks.